I assume we're still on trig?
Yeah.
Okay, let's just review. Tell me what, from this picture, tell me what the sine of theta is.
So we're working from the A.
This is where everything begins. Sokotoa. Make sure you have this memorized and never forget it. So what's the sine?
So 4/5.
Opposite. Sine of theta, not sine of alpha. Sine of theta.
Okay. So that would be 3/4.
3/5. In other words, it's opposite over hypotenuse.
Okay.
What's the sine of alpha? The other angle.
That'd be 4/5.
Good. What's the cosine of theta?
COS. That'd be
CAH. That's what you want to remember.
Okay, so that'd be also.
You're not figuring it out from the O and the S there. You're figuring it out from the A and the H.
Okay. That one would also be 4/5.
And what's the cosine of alpha?
3/4.
And what's the tangent of theta?
3/4.
And the tangent of alpha?
4/3.
All right. You want to get really good at that. In other words, they say with trig, you don't want to memorize it. You want to learn it like you know your name. When somebody says to you, what is your name? You don't scan your memory banks and, oh, Mark. You know it instantly. That's how good you want to get at trig. Now, you may not have to be that good this year in geometry, but when you take trig, you'll want to get that good. It's a foreign language. You want to be able to speak the foreign language. Okay?
Okay.
Now, why is this useful? Well, it's pretty useful in analyzing triangles. Let's say you got a tree right there.
Okay.
And you're 50 feet, let's say you're 40 feet away from the tree. You're standing right here. And you take your surveying instrument and you point it at the top of the tree and you discover that that's a 42-degree angle.
Okay.
Without trig, we have no way of calculating the height of that tree. But with trig, we do. What equation can I write that's going to allow me to calculate y? Always, when you're writing these equations, always start with the trig function on the left side. In other words, the very first thing I want to write is either sine, cosine, or tangent. What should it be here?
Well, you're going to use tangent.
Right, because the only two values I've been indicated are the opposite and the adjacent. So I can say the tangent of 42 degrees equals y over 40, which makes y equal to 40 times the tan of 42. Now, I have no idea what the tangent of 42 degrees is, but my calculator does. So all I have to do is stick that into my calculator. Do you have your TI-84?
Yeah.
Why don't you grab it, because there's one thing you got to make sure you're doing here.
I already changed it from radicals to degrees.
Okay. It's not always obvious which one it's in. So you have to go to mode and check. Because
Yeah.
if you type
I had my teacher change it.
type in 40 times tan of 42 and you're in radians, it's going to treat the 42 as radians and give you a completely different answer. So you have to know whether you're in degrees or radians in order to do these on your calculator. So what did you get when you typed 40 times the tan of 42?
Um, 36.
Yeah.
0.0.
And that makes a lot of sense. Because I know that if this were 45 degrees, then this side is going to be the same as this side, right?
Yeah.
It would become an isosceles right triangle. So the fact that this is less than 45 degrees means this side should be slightly smaller than 40. And it is. It's always a good idea on these problems to have a ballpark idea as to what the answer should be. The reason is that if your calculator was accidentally in radian mode, it's liable to give you an answer of 135. And you'd instantly look at that and say, well, that doesn't make any sense that it's that tall. I must have been in radian mode instead of degree mode.
Okay.
So doing these ballpark checks is really helpful to catch errors. Okay? So I'm able to determine the height of that tree by knowing only two things: the distance I am from it on the ground and the angle that it makes, the angle of inclination.
Okay.
You can always get this with some sort of a surveying instrument. Now, there's a pretty clever use of trig where I like to use the examples of the first settlers that were traveling west. Okay? 100 miles away from Denver, they spot Pikes Peak. They're in their little wagon train here. They're moving this way, and they spot Pikes Peak. Well, using trig, you can figure out how tall Pikes Peak is and how far away from it you are, even if you don't know that. In other words, they didn't know they were 100 miles away from it. They just got to a point near, 100 miles east of Denver where they looked up and they saw Pikes Peak. And clearly, the two most important questions they had was how tall is that mountain, because we may have to cross it. And the second one is how far away are we from it? Well, by using trig, they could take that angle. They could move forward 1,000 feet, very small distance, take that angle again, and now you're going to have two equations, two unknowns. You can solve for both your distance from the mountain and the height of the mountain, which is pretty amazing that you can do both of those things without knowing that you're 100 miles. You might be, 500 miles. You might be 10 miles. So knowing how far you are is pretty cool. And knowing how high the mountain is pretty cool. I won't go through this math because it's a little more complicated than they're giving you, but it definitely illustrates the value of trig, because so many things in the world are dealing with right triangles. Telephone poles stand at right angles to the earth, buildings stand at right angles to the earth, cliffs tend to stand at right angles from the earth. So you can always turn them all into right triangles. Now, they don't cover much trig in this chapter. They do the tree problem. They do everything we've done. They do one additional thing, and that is trig identities. So let's just talk about those for a second.
Okay.
Always. No matter what theta is. In other words, if I had the sine squared of 30 degrees plus the cosine squared of 30 degrees, that's got to equal 1. Don't believe it? Well, what's the sine of 30 degrees? That's 1/2. So 1/2 squared. Cosine of 30 degrees is square root of 3 over 2. If I square that, well, this becomes 1/4. This becomes 3/4. 1/4 plus 3/4 adds to 1.
Okay.
So, no matter what that angle could be 19 degrees, it could be 150 degrees. If I take the sine of that angle and square it and add it to the cosine of the same angle and square that, always going to add to the number 1. And that's a hugely important identity in trig. In other words, trig is all about changing expressions from one thing to another. So knowing this top identity is huge. And incidentally, there's a big difference between this. This means the sine of x times the sine of x. This means sine. First I'm going to square x, and then I'm going to take the sine of it. Okay? So you don't see this one very often, but you see this a lot. There's a lot of sine squareds, cosine squareds, tangent squareds, all of that. So this is the most important identity, and that's the only one they're giving you in geometry class. And they give you one more. The tangent of theta is always equal to the sine of theta divided by the cosine of theta. Again, regardless of theta. Doesn't matter if theta is 0, 45 degrees, 49 degrees, doesn't matter. These two identities are true. And those are the only two listed in the geometry book that I have. All right. Do you have any problems you want to send to me and go over, or have you sent them to me?
I don't have any today.
That's fine. I can come up with some, certainly. Let's do one more practical problem. We have an escalator that's at a 30-degree angle from the ground. And we know that the floor we're going to is 76 feet higher than the floor we're on. Solve for the length of the escalator. So, we solve all of these problems by trying to write an equation. And when you're trying to write the equation, always start with the trig function. Don't ever start with the stuff that should be on the right side. That's a helpful hint. Always start with the trig function. So you got your choice, sine, cosine, or tangent. Which one should I use?
Sine.
Okay. Give me the equation.
76 times sine 30.
Hold on. Let's just write the equation out, not solve it all in one step. That's a big part of trig. You want to always write the equation out before you attempt to solve it. Sine of what? We need an angle right there. We only take trig functions of angles. So what goes here?
30 degrees.
What's that equal to?
Equals D
Oh.
over 76.
So what's the O and the H stand for?
Oh, 76 over D.
Okay. Now solve that for D. First of all, if you look in your calculator, the sine of 30 degrees is 1/2. Well, but let's solve it for D first of all. D, if I multiply both sides by D and divide both sides by sine of 30, I get this. Right?
Yeah.
Okay. Now you go into your calculator and you come up with a number for that. What do you get?
It says 152.
That's correct, because the sine of 30 degrees is 1/2. So I'm dividing 76 by 1/2, which means I'm going to flip the denominator and multiply, and I get 152.
Okay.
Okay.
That makes sense.
Now, there are some that it's really worth memorizing, and those are our two special triangles. What are the dimensions on this? What's this side?
30, 60, 90.
Right. What are the dimensions on the outside of my unit triangle?
Oh,
By that,
shoot,
I
this
mean
is...
the side opposite the smallest angle has to be 1.
Okay.
Now what's this side here?
Oh, 1 square root 3.
What's this side up here?
1 times 2.
Times 2. There's that special triangle and this special triangle. And what this is going to allow me to do is memorize my trig functions for these special angles of 30, 45, and 60. That's 1 square root of 2. So let's go through them. What's the sine of 30?
That'd be, let me look real quick. Sine, oh, that's the inverse. Sine 30. That's 0.5.
1 over 2. Let's leave it as ratios. In fact, I'd rather you not use your calculator here.
Okay.
You'll notice you don't need your calculator because you can get all of these answers by looking at these two triangles. What's the sine of 60 degrees?
That one is just 1/4.
What's opposite of the 60-degree angle?
Oh, 30.
That's the opposite angle. I want the opposite side. Always the opposite side. When I say so, that's the opposite side over the hypotenuse. So what's the sine of 60?
Opposite. That's 1 over 2.
No, that was the sine of 30. 1 is the opposite to the angle 30. What's the side opposite the angle 60?
Okay, square root 3 over 2.
Okay. And what's the sine of 45 degrees?
Isn't the only other... Okay, 45 would be 1 over square root 2.
Okay, and that does need to be rationalized, so it ends up being square root of 2 over 2.
Okay.
Okay, memorize these, not necessarily this year. But when you take trig, you're going to have to memorize all trig functions of these three angles. It's cosine of 45.
Cosine of 45? Okay, so that's...
Just read the picture.
Okay, so that's 1 over square root 2 again.
Correct.
Which would be square root 2.
So the cosine of 45 degrees is the same value as the sine of 45 degrees. It's tangent of 45 degrees.
That's just 1.
It's the tangent of 30 degrees.
One square root 3.
1 over square root 3?
Yeah.
Rationalize that?
To square root 3 over 1.
Square root of 3 over 3.
Okay.
Okay. And finally, what's the tangent of 60 degrees? We'll start with the angle. Find the opposite side. Put it over the adjacent side.
Square root 3 over 1.
Which is just square root of 3. That's what you do. And that's one of the reasons these two special triangles, I put so much emphasis on them when I teach students, is not only are they extremely important to geometry, but they're incredibly important to trig. Because they want you to be able to do these without a calculator. They're not going to allow you to use a calculator to find the tangent of 60 degrees. They're going to expect you to know that it's square root of 3. All right, good place to stop. That's probably going to be the end of our trig. I noticed the very next chapter is now solving right triangles with angles. No, it's not the end of trig. We'll still be doing more trig next Tuesday, I imagine.
All right.
All right? All right, Mark. You have a good weekend, and I will talk to you Tuesday.
All right. Thank you, David.
Bye-bye.